NAD+, or nicotinamide adenine dinucleotide, is a coenzyme found in every living cell, playing a central role in cellular energy metabolism and DNA repair. It serves as a molecular bridge between the food we eat and the energy our bodies use, enabling the complex biochemical reactions that keep cells alive and functioning. But NAD+ is more than just a metabolic assistant. It's a critical regulator of cellular health, aging, and resilience. As we grow older, our NAD+ levels decline significantly, contributing to many of the biological hallmarks of aging. This has led scientists and longevity researchers to explore whether restoring NAD+ levels, particularly through supplementation, could help rejuvenate cells and slow, or even reverse, aspects of aging. The decline in NAD+ begins surprisingly early, with levels in middle-aged adults often just half of what they were in youth. This reduction affects many core functions. First and foremost, low NAD+ compromises the function of mitochondria, the cell's powerhouses. Without sufficient NAD+, mitochondrial energy production falters, leading to fatigue, slower metabolism, and reduced tissue repair. Beyond energy, NAD+ is also required for the activity of sirtuins, enzymes that regulate inflammation, stress resistance, and gene expression patterns that influence longevity. Sirtuins depend on NAD+ as fuel, meaning that as NAD+ declines, so does the ability of cells to protect themselves from damage. One of the most exciting roles of NAD+ is its involvement in DNA repair. Every day, our cells experience thousands of DNA lesions due to environmental stress, oxidative damage, and natural cellular processes. PRP enzymes, which coordinate the repair of DNA breaks, are heavily dependent on NAD+. As levels drop, repair becomes less efficient, and mutations accumulate, contributing to cancer risk, neurodegeneration, and cellular aging. Restoring NAD+ may thus allow cells to catch up on years of unrepaired damage and rejuvenate their internal machinery. This understanding has spurred the development of NAD+ precursors, molecules like nicotinamide riboside, NR, and nicotinamide mononucleotide, NMN, which the body can convert into NAD+ more efficiently than through food alone. Animal studies have shown that supplementing with these compounds can restore NAD+ levels, improve mitochondrial function, enhance endurance, increase insulin sensitivity, and even extend lifespan in certain models. In older mice, NMN supplementation has led to improvements in muscle strength, cognitive performance, and even restored some aspects of youthful physiology. In humans, the results are still emerging, but early trials are promising. Supplementation with NR or NMN has been shown to safely raise NAD+ levels in the blood and tissues. Some studies report modest improvements in blood pressure, muscle function, lipid profiles, and markers of inflammation. Others suggest possible benefits for neurodegenerative conditions or age-related cognitive decline, though larger and longer studies are needed to confirm these effects. What makes NAD+ restoration particularly exciting is its potential to synergize with other anti-aging strategies. For example, caloric restriction, intermittent fasting, and exercise all naturally increase NAD+ levels by inducing mild metabolic stress. Supplementing with precursors may amplify these effects, providing the body with more raw material to support energy production, DNA repair, and cellular renewal. In this sense, NAD+ is not a silver bullet, but a central hub that coordinates multiple pathways of aging, making it an ideal target for longevity-focused interventions. It's important to note, however, that not all NAD+ supplements are created equal. There are questions about how much of the orally ingested precursors actually reach target tissues, especially the brain. Bioavailability and dosage remain active areas of research. Likewise, while boosting NAD+ appears safe in healthy individuals, long-term effects are not yet fully understood, particularly in those with existing health conditions. Because NAD+ also fuels repair mechanisms in cancer cells, some experts caution that its use should be carefully monitored in high-risk populations. Still, the overall picture is remarkably hopeful. Rather than simply managing the symptoms of aging, NAD+ supplementation offers a chance to restore the machinery of life itself, to revitalize cells from the inside out. It targets foundational processes that underpin energy, resilience, and repair, offering benefits that ripple across organs and systems. Whether used alone or in combination with lifestyle interventions and other emerging therapies, NAD plus restoration may become one of the most effective tools in the longevity toolkit. As research continues to refine our understanding of how best to boost and sustain NAD plus in humans, the potential for improving not just lifespan but health span, the number of years we live free of disease and decline, is within reach. For those seeking a science-backed, cellular-level approach to aging, NAD plus may represent one of the most promising frontiers in modern biomedicine.